Hi, my name is Nuhumaira Akila Binti Yusri Azli. My match number is A2280705. I will present an article about implementation of blockchain technology in the European Union energy payment and logistic. The study provides a clear rationale for exploring the role of blockchain technology in the European Union's energy sector, specifically focusing on logistic and payment system. The author highlights how the current system used for managing energy transactions in the EU suffer from several limitations, including lack of transparency, vulnerability to fraud, delays in payment processing, and data manipulation risks due to centralized control structures. In response to these challenges, the study proposed the development of a blockchain-based framework to improve the security, trustworthiness, and efficiency of these processes. Blockchain core features such as decentralization, immutability, and automatic smart contracts are identified as key solutions that can help overcome the weaknesses in the existing infrastructure. I will continue the issue and problem highlighted. First, the lack of transparency and trust among stakeholders. Existing systems are often fragmented and operate in silos, making it difficult to track transactions accurately or ensure that all parties have access to the same verified information. Second, the centralized nature of data control. The system is vulnerable to tampering, fraud, and manipulation when data is stored and managed by a single authority or a small group of entities. It creates potential point of failure and opens the door to unauthorized changes or error, whether intentional or accidental, that can compromise the integrity of the entire system. Lastly, the reconciliation of cross-border payment. The EU energy market is often slow and inefficient due to the involvement of multiple regulator system, currency, and intermediaries. This complexity increases transaction costs and processing time, making it difficult to maintain real-time accuracy in financial settlement. Next, suggestion methodology used. The design science research methodology adopted in the article is primarily qualitative in nature, though it incorporates quantitative techniques during the evaluation phase. At its core, focus on designing and creating innovative solutions to real-world problems through a structured iterative process. The design and development stage, where the blockchain architecture and smart contracts are created, also leans toward a qualitative engineering process. It involves system modeling and the logical structuring of technological components rather than statistical analysis. However, once the prototype is developed, the demonstration and evaluation stage introduce quantitative elements to validate the system effectiveness. They meet running simulation of performance tests to generate measurable data such as transaction processing speed, network latency, throughput, and computational costs under various consensus mechanisms. Next is recommendation and solution. Initiate system integration through pilot project in selected EU energy corridors. This pilot implementation can test the blockchain model under real-world conditions, including cross-border operation and high transaction volume, allowing for adjustment before large-scale adoption. Pilot testing allows stakeholders to evaluate the system, technical performance, resilience, scalability, and interoperability before committing to a full-scale rollout. A robust governance framework should be established to oversee the blockchain network. This should include participation from key stakeholders such as regulatory bodies and energy market participants. Their involvement will help ensure node integrities, establish a clear rule for consensus protocol, and build trust across the ecosystem. Achieving full functionality requires interoperability standard, particularly open and standardized data structure to allow existing enterprise resource planning system and other legacy infrastructure to communicate effectively with the blockchain system. In conclusion, the article effectively illustrates the potential of blockchain-based system to transform the EU energy logistic and payment infrastructure by significantly enhancing data integrity, transparency, and stakeholder trust. By leveraging the decentralized temporary system and automated nature of blockchain, the process model addresses many of the long-standing inefficiency and security vulnerabilities in the current system. However, the shift from theoretical design or simulation to real-world implementation presents several challenges. These include the need for a strong governance structure to manage the network, value the development of interoperable systems that can communicate across different platforms and jurisdictions, and the establishment of continuous performance monitoring to ensure the system operates effectively at scale.